Find the partial fraction decomposition of the rational function x to the fifth minus 2x to the fourth plus x cubed plus x plus 5 over the quantity x cubed minus 2x squared plus x minus 2. Observe that the degree in the numerator is 5 and the degree in the denominator is 3, so we can't perform partial fraction decomposition, not yet, unless we perform long division and turn this into a proper rational, a proper fraction. A proper fraction is a fraction where the degree in the numerator is strictly less than the degree in the denominator. So first, we would need to perform long division. With x to the fifth minus 2x to the fourth plus x cubed plus x plus 5 in the numerator, we divide it by x cubed minus 2x squared plus x minus 2. To perform long division, we should put in the placeholder for 0x squared as well. First, we take x to the fifth, which is the leading term, divided by x cubed, we have x squared. And then we multiply this back. X squared times x cubed is x to the fifth. X squared times negative 2x squared is minus 2x to the fourth. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. And we will subtract these column-wise. X to the fifth minus x to the fifth is gone. Negative 2x to the fourth minus negative 2x to the fourth, gone. X cubed minus x cubed, gone. 0x squared minus negative 2x squared is now positive 2x squared. And we bring down x and 5. We stop because the degree of 2x squared is 2 and the degree of the divisor is 3, and so 2x squared plus x plus 5 is what we know as the remainder. X squared is known as the quotient. X cubed minus 2x squared plus x minus 3 is the divisor. And so, the given rational expression can be rewritten as x squared plus the remainder 2x squared plus x plus 5 over the divisor x cubed minus 2x squared plus x minus 2. And this rational expression is now proper. This is a proper fraction. We will perform partial fraction decomposition on this rational expression only. To do that, we first need to factor x cubed minus 2x squared plus x minus 2. We can do this by grouping the first two terms. We can factor out x squared, x minus 2 left, and we have 1 of x minus 2. This is x minus 2 times x squared plus 1. X minus 2 is a linear factor and x squared plus 1 is an irreducible quadratic factor because x squared plus 1 can never be 0. And so the given rational expression, let's call it f of x. We did long division and we have x squared plus 2x squared plus x plus 5 over x cubed minus 2x squared plus x minus 2. We will keep the x squared term, so we rewrite it, but with this rational expression, we put it in the form of partial fraction decomposition. This is now 2x squared plus x plus 5 over x minus 2 times x squared plus 1. And so the partial fraction decomposition form of f of x, which we will rewrite it, f of x equals x squared plus x minus 2 is linear, so we only need to have a constant a on the top in the numerator. X squared plus 1 is an irreducible quadratic factor, so we would need the linear term in the numerator, which is bx plus c. We must have 2x squared plus x plus 5 over x minus 2 times x squared plus 1 equals a over x minus 2 plus bx plus c over x squared plus 1. And don't forget the x squared. There are three unknowns a, b, c, which means we will need to solve a system of three equations. To avoid working with a system of three equations, we will use the cover up or the heaviside methods to find the coefficient on top of the linear factor x minus 2. To find a, we would plug in x equal 2 on the left hand side while covering the factor x minus 2. We won't be able to plug in 2 into x minus 2 in the denominator, and that is why we cover this. The numerator is 2x squared plus x plus 5, and we evaluate this with x equal 2. So this is 2 times 2 squared plus 2 plus 5 over 2 squared plus 1. 2 squared is 4, 4 times 2 is 8, 8 plus 2 plus 5 over 4 plus 1. And this is 15 over 5 or 3. And so a equals 3. We then update the partial fraction decomposition form. 2x squared plus x plus 5 over x minus 2 times x squared plus 1 equals a over x minus 2, but we found a equals 3, plus bx plus c over x squared plus 1. We still need to find b and c, and to do that, we need to combine the two fractions on the right hand side with the least common denominator, x minus 2 times x squared plus 1. We need to multiply 3 with x squared plus 1 and bx plus c with x minus 2. We then distribute or simplify the numerator further. The numerator is 3x squared plus 3 plus bx times x is bx squared. Bx times negative 2 is negative 2bx plus cx minus 2c over the least common denominator. And again, this must be the same as 2x squared plus x plus 5 over the same denominator. We then combine the coefficient on the left and on the right hand side. The coefficient on the left hand side of x squared is 2. On the right hand side, the coefficient in front of x squared are 3 and b. 3x squared plus bx squared. The coefficient of x on the left hand side is 1. The coefficient of x on the right hand side is negative 2b plus c. The constant term on the left hand side is 5, and the constant term on the right hand side is 3 minus 2c. From this system of equation, we see that b equals 2 minus 3 or negative 1. From the last equation, we have 5 minus 3 is 2. 2 equals negative 2c, so c equals 2 over negative 2 or negative 1. Once we have b and c, we are done. But let's double check to see if the middle equation is also correct. The middle equation states that 1 equals negative 2 times b plus c. Negative 2 times negative 1 is positive 2. 2 minus 1 is indeed 1. And so we have b and c. To summarize this, we have a equals 3, b equals negative 1, and c equals negative 1. We now put all of these together. the given rational expression was x to the fifth minus 2x to the fourth plus x cubed plus x plus 5 over x cubed minus 2x squared plus x minus 2. We perform long division and obtain the quotient x squared with a proper fraction, and that proper fraction is 3 over x minus 2 plus bx plus c, but b is negative 1 and c is negative 1 as well, over x squared plus 1. And this is the rational decomposition of the given rational expression. This is x squared plus 3 over x minus 2, and if we factor out the negative 1, the numerator is x plus 1. The denominator is x squared plus 1.